Okay, so this project is Federated IAM for compute services. It's a clearly important topic. It's been name checked in the two talks before coffee. Peter talked a lot about it yesterday. I'm going to try and keep this, fairly strategic. Looking at the fairly high view rather than getting down to technology, which isn't actually what's important, and also trying to see where it impacts users. What can this actually do for users? I am for NFCS. It's always good to give your definitions. What do I mean by IAM? Because people often use the same terms and it can mean different things. IAM stands for Identity and Access Management. It's a subset of authentication and authorization. It's which is a very, very wide-ranging concern. It covers everything. It's underpinning plumbing. You need it sort of everywhere. To me, IAM is more limited. The entities that are being, managed are human beings. So for me, machine to machine, this kind of stuff is out of scope. It's about human beings and it's about the human interface. So what I want to look at is what will a national federated compute service need in terms of IAM? The landscape already contains significant IAM in compute services. Can we have a look at that landscape? What are the gaps between what we have and what we need? I also want to say, what I mean by federation. That's another term that everyone has a different definition. You look at the dictionary, federation is where multiple distinct and different organizations work together to provide a goal. It is not just a technology problem. Technology is just a tool you use to do a federation. It's about people, it's policies, agreements, staff and procedures to support things. Really, the way you solve this is say, we need a team to do this. We need funding for that team to do stuff. They can choose the technology to some extent, forums, etc. It doesn't have to be all the way up. There's different levels of federation. One of the things you want is scope for differences. What is a scope as a federation? A postal federation only looks at mail. A political federation looks at other things. There's different things here. This is sort of different levels, different approaches to a large-scale distributed compute. There's different ways of approaching this problem. Some of which are federations. Right at the top, you have a distributed infrastructure. Where you have massive scale, but it's all run by one organization. In political terms, this is the Roman Empire, not a political federation. That's like, they have one software stack that they roll out everywhere, like the Romans had, one military thing, the same camp appeared all over Europe. Public cloud is like that. And, it's one software stack just spread everywhere. Early 2000s, you had the concept of the grid. The key thing they wanted there, it's not the only thing you can want with the federation, but what they wanted was fungible, interchangeable resource. You could run your job anywhere interchangeably. The name came from the electricity grid. You could plug in any plug. You have multiple providers, but they're doing a very, very uniform thing. You have an overhead. It's a lot harder to manage with multiple providers, but you do get the digital sovereignty and you do get the lack of risk and so on. The easiest way of doing that is to really do what the people above did, have a common software stack. And we saw talks, earlier today. Also, that's the easiest way of doing it. Say, we will run this software everywhere. You can have a much more loose federation where you do bits and pieces. And that's possibly one way of building things, add bits at a time. It allows more diversity and flexibility. It allows you to cross over into federations which are doing things other than compute, like data. A lot of people here are interested in data. There, you may have multiple providers, governance for the individual federation bits only. There, because you have to interoperate so much more, you have to work much more, as we said many times, with the open standards, defined interfaces, this kind of things. And finally, what happens if we don't do anything? Well, by default, you have lots of, compute infrastructure that's all defined independently. There will be similarities. Lots of choices are fairly obvious, and you can look around and say, okay, this is the same, this is the same, these bits are different. That's what happens if we do nothing. Because I'm interested in human IAM, it's the human digital interface, which is the important thing. That's what the users see. Tokens and everything at the back end is of interesting to developers, but a biologist is, it's a human interface that they're hitting. And the primary thing, the thing we really, really care about is the web these days. And that's sort of in many ways the future. I mention SSH because if you look at HPC, we use that a lot. I don't think it's the important thing to concentrate on the strategy. The importance may be declining, it may be going away. And it has its own scheme that works good enough, and particularly for the people who are prepared to use a command line, they're used to it. Things are sort of there. We don't need to mess with it too much. And if you really want to tie them together, though I don't necessarily see it's necessary, there's all sorts of schemes that people have developed that you can just sort of plug in. So what's the landscape? Now, important thing to talk about is the existing UK Access Management Federation. By the name, it's been around for decades. This is what we have. This is, if you search for it, it's over 20 years old. It's part of the EduGain Interfederation. So it's actually part of a much, much bigger thing. And probably I refer to as EduGain going on, but the UK bit is UKAMF. It's incredibly important and it's highly valuable for single sign-on authentication, for logging in, because it has enormous coverage. It happens to use SAML. That's not important at the strategic level. It may change over time. But the structure, the way it operates, not the technical limitations, but what it's been set up by, is effectively, it's a federation of higher education institutes and further education as well, and service providers. And its key core demonstrated use case is reading online journals. So all of the attributes that come from the HEIs, things that your HEI central IT knows. So your identities are tied to your job, which is good for some things, not for others. And the kind of accessibility you're typically doing, because I'm interested in access management as well as identity, is staff, students, institution. That's all the journal really is interested in. It doesn't actually even want to know who you are. You can get it if you want, but it's not important. However, this, as we'll see later, doesn't really cover compute services and lots of other things. So what we see in the current landscape, as Peter said yesterday, is people build their own layers below, just like life sciences logging did. So many communities run their own IAM services layered underneath and providing additional functionality. Typically at the moment as a single proxy service. That is a technical choice. It's what works at the moment. It may not be how things always work. There is, this is known space. We don't have to design this. The ARC project has done that for. There is a blueprint out there for doing this stuff with best practice and so on. It's not a fixed document. It evolves. Thinking evolves. Updates come out. But there is something to track, to look at. If you're starting to diverge from that wide consensus, you're doing something wrong. Many communities operate across multiple countries and multiple compute federations. Another reason sort of stick within the envelope. There are trends in technology, but as I said, that's not strategic. There's lots of existing examples even in the UK. RSIAM is exactly doing, it's a compute federation. DIRAC is a compute federation. Life science AI, my extension is slightly interesting because it does identity and login. We heard earlier today the groups, the projects they've put in the allocation system. So kind of requirements. What would users want? Users may interact with multiple different websites. They want consistency. They don't want to be having to log in 20 times a day. They don't want to be doing it in a different way every time they do. EduGain solves that. Solve problem. That EduGain solved it by single sign-on. Which is very, very nice for non-technical users because they do it the way that their local IT has taught them to do and can support and can help them with. There are other ways of doing it, but in many ways, that's a no-brainer. Access management for compute is much more interesting. Now, there are different requirements. Every community has its own thing. In a lot of the big compute, Archer 2, for example, we have the project you have compute shortage. The thing about compute is exclusive access, and you only use it once, so you can't just give it to everybody. Often it comes from a grant, and the grant holder has a certain group of people that he wants to give access. But it's not just people from his own institution. He's got half a dozen PhD students, an RSC, an industrial collaborator, his friends from school who he always works with. These people come and go over time. It's dynamic, and it's controlled by the academic. So he needs a way of being able to form those groups. Other areas, like life sciences, have different requirements. But that's one use case that we have to be able to do. Identity, we've talked a lot about Federation ID. I think it's, makes all things useful. I would push for it to be human readable, just because some of the Federation stuff is not going to be automated. You're going to have conversations, you're going to have instant management. And it's quite nice if your brain can see an ID and say, I'm sure I've seen him yesterday doing something funny. It doesn't necessarily, you don't have to necessarily say, I know exactly who that person is and his passport number, but JFreddy3 has been doing something funny for a long time. And it's nice if your human brain can recognize it. Dirac do that, and I think it's one of the good things that Dirac do. Offline access is important because it's compute runs when the users aren't in there. So sometimes you need access to these attributes when people aren't logged in. I have a few diagrams. What I think is we need our own service. We've talked about My Access ID, but first of all, let's say My Access ID is doing identity and login with the access control elsewhere, and just the bandwidth. You need people to respond to changes, respond to problems, work on the thing. You need your own team, and for that reason, you need your own piece of software where you can make those changes. And we have things. I mean, put IAM there and work from there would be my suggestion. I'll call today there.
Thank you.